The idea that caffeine, a humble stimulant most of us casually sip each morning, could help fend off devastating age-related diseases like Alzheimer's and cancer sounds almost too good to be true. But as research piles up, caffeine is quietly emerging as a surprisingly versatile molecule with a growing list of biological superpowers. It's neuroprotective, anti-inflammatory, and may even have anti-mutagenic effects. While it's not a cure, the evidence suggests caffeine may play a protective role across multiple aging-related pathways, making it more than just a daily habit. It might be a daily hedge against decline. Let's start with the brain, where caffeine has shown its strongest and most consistent performance. Numerous observational studies have linked regular coffee and caffeine consumption with a reduced risk of neurodegenerative diseases, especially Alzheimer's and Parkinson's. People who drink 2 to 4 cups of coffee per day tend to have a 25 to 30% lower risk of developing these conditions later in life. This protective effect is thought to arise from several converging mechanisms, not just the fact that caffeine keeps you alert. One major route is through caffeine's effect on adenosine receptors, particularly A1 and A2A. In the brain, adenosine is a neuromodulator that builds up with fatigue and promotes sleep, but it also promotes inflammation and slows neuronal firing. Caffeine blocks these receptors, leading to enhanced dopamine signaling, better memory retention, and, critically, reduced neuroinflammation. Since chronic inflammation in the brain is one of the early drivers of Alzheimer's pathology, caffeine's ability to tone it down is like dampening the kindling before the fire ever starts. Beyond inflammation, caffeine also appears to reduce the buildup of beta-amyloid plaques and tau tangles in animal models, those infamous markers of Alzheimer's disease. Rodent studies have shown that chronic caffeine intake reduces amyloid levels in the brain and improves cognitive function, possibly by promoting autophagy, the brain's natural cleanup system, and improving blood-brain barrier integrity. Essentially, caffeine might help keep the brain's janitorial staff on duty longer, delaying the buildup of toxic waste. On the cancer front, caffeine shows a different but equally intriguing pattern. While the relationship between caffeine and cancer risk is complex and highly dependent on the cancer type, some mechanisms suggest real anti-mutagenic potential. Caffeine has been shown to inhibit DNA damage caused by certain carcinogens and enhance the DNA repair process through modulation of ATM/ATR enzymes and cell cycle checkpoints. In other words, caffeine might help cells detect and correct mutations before they spiral into malignancy. Additionally, caffeine can selectively induce apoptosis, programmed cell death, in damaged or precancer cells, especially in tissues that turn over rapidly, like skin, colon, or liver. Combined with its ability to suppress chronic inflammation, a known cancer driver, this positions caffeine as a kind of molecular filter, helping eliminate troublemaker cells before they start multiplying recklessly. Some epidemiological data back this up. Moderate coffee intake is linked to a lower risk of liver, colorectal, endometrial, and even prostate cancers in several meta-analyses. There's also the antioxidant effect to consider. While caffeine itself is not the most powerful antioxidant in coffee, it works synergistically with polyphenol and other bioactive compounds like chlorogenic acids to reduce oxidative stress throughout the body. Oxidative stress, in turn, is a well-known contributor to both neurodegeneration and tumor initiation. By dialing down free radicals and boosting the body's own antioxidant defenses, caffeine-rich beverages may provide low-grade, daily resilience against molecular wear and tear. That said, caffeine's protective effects aren't universal, and the more is better mindset doesn't always apply. Excessive caffeine can spike cortisol, disrupt sleep, raise blood pressure, or trigger anxiety, all of which can undermine long-term health. Moreover, genetic differences in caffeine metabolism, especially variants in CYP1A2, mean that some people process caffeine quickly and benefit from it, while slow metabolizers may experience more negative effects. In other words, caffeine's benefits are context-dependent and highly personalized. What we do know is this: caffeine touches multiple systems that are deeply involved in aging and age-related disease, neurotransmission, inflammation, DNA repair, mitochondrial function, and cell cycle control. It acts on pathways conserved across evolution, from fission yeast to human neurons, and its mild, daily stimulation may create just enough stress to activate cellular defenses without tipping into damage. It's the Goldilocks principle of biohacking, just enough challenge to make the system stronger. So, while no doctor is prescribing espresso shots as Alzheimer's prevention or an anti-cancer treatment yet, the emerging science is pointing in a fascinating direction. Caffeine may not be a magic bullet, but it's shaping up to be a metabolic multitasker with legitimate protective effects against the molecular drivers of age-related disease. Whether you're drinking it for the flavor, the focus, or the subtle genetic support, your morning coffee may be doing a lot more than keeping you awake. It might just be helping you age a little